Okay, I'm going to show you how to do the guesswork for one of the problems in the problem set. This time we're going to do number 22 from the problem set. Car slows down from 28 meters per second to rest. At that distance, what is the acceleration assumed constant? Because of course we need to assume constant acceleration in order for our kinematics expressions to work. So first thing I'm going to do is I'm going to go through my guesswork step by step. All right, the G in guesswork stands for givens. So I'm going to list all my givens. So I see the car slows down from 28 meters per second. Stop. 28 meters per second is a speed or a velocity. In this case, that's the very first one that I'm given. So that's the initial velocity. It says it slows down from that speed or from that velocity. So it's 28 meters per second. And it slows down to rest. Stop. That's telling me something there. It's slowing down to rest. That's actually my final velocity. 0 meters per second in a distance of 88 meters. During the course of that 88 meters, it went through a change in position, the car did, of 88 meters. So I believe that's all of my givens. And then it asks, what is its acceleration assumed constant? Stop. What is its acceleration? That takes me to the next step of guesswork. The U stands for unknown. My unknown is acceleration. And again, notice I am using the standard accepted variables for each of these values because eventually I'm going to be looking at my equation sheet to figure out which one of those kinematic expressions fits. So now I've got to go through my kinematic expressions. I've got an initial velocity, a final velocity, a displacement, and an acceleration. So I take a look at that first equation. I've got final velocity, I've got initial velocity, check. Acceleration, check. Time, oh, wait a minute, I don't have time. That one's no good. All right, next. Now this one, they write this a little bit funny, but what they've done is they've separated the initial and final position, but really these two things together represent the change in position. So I've got change in position, check. I've got initial velocity, check. Time, uh-oh, no time in my variables. That one disappears. Sure hope it's this last one. Final velocity, check. Initial velocity, check. Acceleration, check. This together is change in position, otherwise known as displacement, check. This is the equation I'm going to use. So now I'm going to rewrite this equation without putting any numbers in. All right, so final velocity squared is equal to initial velocity squared, squared plus 2 times the acceleration times the displacement. So now we've listed our givens, we've listed our unknown, we've written our equation. Now it's time to let's see that. So that takes us to the E. The next S, or the first S, stands for solve algebraically. So what I'm going to do is I'm going to take this and I'm going to solve algebraically for my unknown. So I'm going to circle that so it stands out. So now I've got to do a little algebra here. I've got to get that away from both sides. And then I'm going to have to, so that would leave me with this. Let's see, so that'd be V final squared minus initial velocity squared. And then I still have to get that by itself. So I'm going to divide both sides by that, so that finally, let's see, that cancels out, that cancels out. So finally, I'm left with an expression of showing me that acceleration is going to be equal to final velocity squared minus initial velocity squared over 2 times the displacement. Now I plug in my numbers. The final velocity was 0. The initial velocity was, as I recall, 28 meters per second, quantity squared, over 2 times a displacement of 88 meters. When I do that, I plug it into my calculator, and I get 4.45. And then for units, I've got meters over seconds, but those are squared. So I've got meters squared divided by seconds squared, and then that's divided by meters, so that leaves me with 4.45 meters per second squared. Now, final thing, I'm going to take a look at my SIGs, and I notice that all of the numbers that I put into this, 2 SIGs, 2 SIGs. So that means that my final number should be left down to 2 SIGs. So that is going to be 4.5 meters per second squared. Final answer. Hope this helps. If you still need some sense making, just ask me in class or shoot me a message.